Hi class, this is your teacher Joe, and my voice is a bit funny because I have been sick. Um, so this is really strange for me recording this, but here it goes. What you want to do is get out your Chapter 12 study guide, and I believe we had a few more things to fill out on that. So I believe this is the slide that we stopped at in both classes. So it's the human gene therapy slide. You can still access all of my material the old way, like by going to Chapter 12 and looking at the entire Photoshop or PowerPoint. See, I'm screwing up already. The entire PowerPoint yourself, or you can watch these videos with me. They are only going to be 15 minutes in length each because that's all Screencast-O-Matic allows me to do. So, moving on, I believe if you look at your study guide, under the terms, you should still have CRISPR on the bottom. And then if you flip the page over, you should still have name the human gene therapy success for most cases. And then there's also a question, describe at least 2 possible safety or ethical issues involved with DNA technology that we talked about in class. So we will get those 2 filled out. So in this slide, we're looking at human gene therapy. What you want to do is you take a healthy individual and you cut out the gene for whatever it is that the unhealthy person does not have. You combine that gene into a non-harmful virus vector. You might be saying, what do you mean non-harmful virus? What they do is they take out the genes that would make the virus so it could hurt you, and they put in the genes of choice. So that virus is just going to have the gene that you're missing if you're getting human gene therapy. Now, this is a big deal. I mean, you wouldn't want to do this to change your eye color. You're only going to want to do this if it's life or death. And as we move through this lecture, you will find that this is the way like they used to do it, but now we have a brand new way called CRISPR, which we'll talk about soon. So once you have your non-harmful virus vector with the gene that the unhealthy person is missing, then you're going to inject that into their bone marrow. So let's see how good this is at changing slides. Here we go. So one of the cases, so it says on the back sheet of your Chapter 12 study guide, name the human gene therapy success for most cases. So there is this fatal inherited disease called SCIDS, which stands for Severe Combined Immunodeficiency. Now, you don't need to remember this entire name if this is too tough. But basically what this gene does is it prevents the development of the immune system, and SCIDS patients are going to die very quickly, like at birth, unless they're treated with a bone marrow transplant. So you may, if you were ever a fan of the Seinfeld show, they had an episode on the Bubble Boy, and I think there's also been a movie on the Bubble Boy. Well, this kid pictured on this slide is David Vetter, and he's known as the Bubble Boy. So I'm switching slides. So he lived from 1971 to 1984, and he lived inside this bubble his entire life. His parents knew beforehand that he was going to have this disease. He had an older sibling that had it, and that sibling died. So immediately when David was born, he was placed into this completely sterile environment. He never got to be held or hugged. You can kind of see there are these armholes, glove holes in this place in this bubble that he lives, and that's the only way he was ever touched by humans. So the reason he died at the age of 13 was, as you all know, when you become a teenager, you know everything, and he said, forget it, I'm not living like this anymore. He came out of the bubble and he died. Unfortunately, he lived in this time frame because since the year 2000, gene therapy has successfully cured 22 children with inborn SCID. So on your study guide, it says name the human gene therapy success for most cases. What you want to put there is the bubble boy disease, the kids that grow up without an immune system, or you can put SCID if you like to know the whole full name. Either SCID or bubble boy, some mention of that will get you to the correct answer on the exam. Because if you remember, we're using retroviruses that have their nasty genes taken out, and we've put in the correct gene that these kids needed. We don't always know where that retrovirus is going to incorporate the gene into the recipient. So unfortunately, 3 of the kids that they used this gene therapy on developed blood cancer, leukemia, and 1 of them died. So this is not a procedure you want to take lightly and do lightly. There's some cool information at this link if you'd like to follow up on that. And the part like in the Seinfeld episode where they kind of made fun of this kid, which is really, really sad, but also kind of hilarious, is he had this large ball. Like if you've seen a hamster ball where you can put the hamster in the ball and he runs around, the kid had one of these and he would walk around in his giant bubble. All right, changing slides. Yeah, I'm screwing this up major. Okay, I wonder if you guys can see all the screw-ups I do. So now flip back to your first page, and we have CRISPR on there. So what is CRISPR? It is a technology for changing the sequence of DNA in cells in a precise fashion to correct mutations. This stuff is leading edge. It's really, really cool. I'm going to put some videos for you to watch on your, where it says in D2L March 30th. I will put these links that you need to watch there, plus watching my silly video here that I'm making with lots of mistakes. So the exciting thing about CRISPR is that there is a woman in the South, the United States, and can't remember which state, but she is trying to get her sickle cell anemia cured by using CRISPR. So I will find a fun video on that and I will place that on D2L also. But what you need to know is like the latest thing, and it's a brand new technology for precisely changing DNA. All right, going on to the next